Hello everyone and welcome back to Intelevo. I'm Roshna here. In our last episode, we got Python installed, understood why it is the number one language for AI, and ran our very first code in Jupyter Notebook. If you missed that, the link is in the description box. Do watch it first because we will be building on it today. And today's topic is one of the most fundamental in all programming, that is variables and data types in Python. By the end of this video, you will know exactly how Python stores data, how to name your variables like a professional, what all 35 reserved keywords are, and how to generate them with one line of code. And you will have written a complete Python program from scratch. Alright. Let us start with the absolute basics, that is, what is a variable? You just think of your computer's memory as a giant warehouse full of boxes. Each box can hold one thing. Okay? A variable is simply the label you put on a box so you can find it later. So when I write name Intelevo, what Python does is it takes the value Intelevo, puts it into a memory box and sticks the label name on it. Next time when I use the word name anywhere in my code, Python goes to that box and gives me back what is inside. Actually, in Python, a variable is created the moment you assign a value to it. No declaration, there is no ceremony, just write the name and equal sign and the value. That's enough. Let us look at the code on the screen. We have four variables, that is a string, an integer, a float and a boolean, and we can print all of them in one line of code. That is simple, clean, readable, and that is why we call Python is the simplest language in AI. That is, you can print it like a print of name, episode, rating, active. The output will be like this. You can try it by your own. And now that we know what a variable is, let us talk about identifiers. A word you will hear a lot in Python. An identifier is simply the name you give to anything in Python. A variable, a function, a class, a module, it's just the label on our memory box. And just like naming a file on your computer, there are rules here. Look at the 6 rules on this slide. That is, rule number 1, identifiers can only contain letters, digits and underscores. So A, B or score underscore on all are fine. And rule number 2 is it must start with a letter or underscore, never a digit. So if you write like to name without any space, NAME, that is illegal. Python will throw a syntax error immediately if you name it like that. And Python, the rule number 3 is Python is case sensitive. That is, the small letter NAME is not equal to NAME, and which is not also equal to the upper, if we put all the letters in the name as uppercase. That also not, these three are different things, not same things in Python. And the rule number 4 is you cannot use keyword as identifiers. We cover keywords in the next slide, but just I am mentioning it is a rule of identifier. We cannot use keywords as identifier. And the rule number 5 is no spaces allowed while naming while giving the identifier. Use the underscore instead. My variable is invalid. Actually, my space variable, if you put that is invalid, you can write it like this: my underscore var, or variable also fine, but you should not put space in between this. And the rule number 6 is no special characters like at, hash, dollar or anything like this kind of this special characters are not allowed. And look at the bottom of the slide, that is my underscore name count underscore count name 2 score 1. These are all allowed, these are all valid, but these are not valid valid in Python. Actually, when you if you put write like this way, Python will refuse to run any of this, and you will get a syntax error in return. And then Python has a set of reserved words called keywords. These words have fixed built-in meaning in the language. You cannot use them as variable names because Python owns all of this, so we cannot take it. Python 3 has exactly 35 keywords. Look at the grid on this screen. You will recognize some of them, like if, else, for, while, def, class, something you may be you can recognize if you are familiar with Python, but don't bother about the other things. And no, you need not by heart this also. You will come familiar with it in the long run, so no need to worry. Now, how do you list all this in programmatically? It's just 2 lines of code. Look at the bottom of this slide. This is we can write it. I will show it in the Jupyter notebook. Here I wrote. You can get all these 35 keywords with 2 lines of code like this. I will show you after running it. This code can generate all the 35 keywords, and you also can try by your own. And if you want the length of this keyword list, you can run this code, and it will generate 35 as output. So if you ever name a variable and Python, gives you a syntax error, you can't explain. If you get a syntax error that you can't explain, check if you accidentally used a keyword. It is one of the most common beginner mistake often happen. So please check whether you have used a keyword as a variable or identifier. Also notice some unusual ones here, like async is there as keyword, and await. All are advanced asynchronous programming things, and that we will learn in the long run. You just know that these are all the keywords which are exist in Python. No need to by heart any of these. And now the most exciting part, that is data types. A data type means a data type tells Python what kind of data a variable holds and what operations are allowed on it. Actually, Python has 8 built-in data types that you will use constantly. Let us go through each card on the slide quickly. That is, first one is integer. We will write as int. For whole numbers like this 42 or -7, 1000, like any number without a decimal, we can these are called integers. And regarding float, for decimal numbers like 3.14, -2.5, 9.8, like anything with a decimal point belongs to float. That data type is float in that case. And then comes the string, that is written as str. For text, anything inside quotes, like inside quote if you write hello, inside quote Python, etc. These kind of things are, this string will look like this. And then come the Boolean, that is abbreviated as bool. It can only be only be true or false, used for conditions and logic in Python. And then comes list. List is an ordered changeable collection, like a shopping list. This is a demo of a list, that is 1, 2, 3 we can write inside square bracket, or you can list like any shopping list, like anything you purchase, you can put it in the square bracket, and that is list. You can list it any category of things, like apple, mango, etc. anything. And then comes the tuple, like a list but logged. Tuple, the difference is the list is not logged, means list we can alter. At any time we can alter the values by giving some codes, but regarding the tuple it is immutable. Once created you cannot change it. Like if you assign some values inside a tuple, it is fixed. You cannot make any changes. Then comes the dictionary. Dictionary stores data in key value pairs like a real dictionary. In real dictionary we know it will be like a word and definition. Like this it is like this is the key and the value of that key is 1. I will demonstrate here. Okay. This is a code to demonstrate this whatever content I discussed in that slide. That is, if you run like this, it is if you want to convert the name to all uppercase, it will be like this, and if you want to slice it like a 0 to 2, actually in Python it the decimal places count from 0 not 1, so 0 to 2 not including 2, it will come like this. So 0 to 2 if we want to slice, it will give only dr. Then this is print hello name means it will a collection of unique elements only, no duplicates allowed. That is, it will be like this curly braces 1 2 3. So you don't need to memorize all of these today. Just know they exist and we will use every single one of them throughout this series. So now let us go deeper into the first 3 types, that is int, float and Boolean. For integers, Python has no limit on how big an integer can be. You can literally compute numbers with thousands of digits. Also notice the underscore trick. That is, if you put like this 1 underscore 000 again underscore 000, it will be the Python read it as 1 million. It is just easier to read, and you can even write hexagonal values directly like this. This Python will take, this is a hexagonal system with a base 16 and it gives you the value 255. And for floats, remember that computers cannot store decimal numbers perfectly in binary. So 0.1 plus 0.2 in Python gives you something like 0.3 and some digital parts like some decimal parts like 0.300 etc. and not exactly 0.3 it will generate. This is called floating point precision, and it is important in scientific computing. That's why we have to use the round-off function. The round-off function will round that to the nearest decimal point, that is you can get exactly 0.3. And then comes the Boolean, and this one surprises many beginners. In Python, true and false are actually integers underneath. True equals 1 and false equals 0. The value false is equal to 0. So you can literally do true plus true and get to interesting, right? And look at the arithmetic operations at the bottom. Don't miss the double slash for floor division and the percentage for modulus and the double star for exponentiation. This will save a lot of time for you. In the live code demo, A comma B, A is assigned to 17 and B is 5. So yeah, you can run it by your own and see what the output will be. Now let us look at the collection types. This is where Python really starts to feel powerful. Strings are sequence of characters. You can do a lot with strings. Look at the code. Name dot upper. This I already explained before. You remember. So this is name dot upper converts everything to uppercase, and name we can also slice, as I mentioned before. Name 0 to 2 means is called slicing. It picks characters from the index 0 up to index 2. So it gives us dr. And regarding the f string here, a string f before the code let you embed variables directly inside a string without any concatenation. This is a modern clean way to format output in Python. And then lists are your go-to when you need an ordered collection that you can modify. You can append, remove, sort and slice lists. In our example, we add functions to the topic list and change the item at index 1. One important thing, Python indexing starts from 0, not 1. It is very important. Python indexing starts from 0 and not 1. So this is a demonstration code. So if we run it, it will like this. It will give value like this. So we have assigned this list to topics. Then if you want to append the function to it, we can simply write like this, topics dot append functions. Then it will add these functions also into this list. So you can write it like this and check it by your own. And to print topic 0, the 0th index is variable and types is 1, loops is 2, and if we append the functions, that will be 3. 0, 1, 2, 3. Okay, I hope it is clear. And then comes the tuples. Tuples look like the list with the round brackets instead of square, but they are immutable, meaning once you create them, you cannot change any element in it. In list, as I discussed before, we can append or remove or make any changes in the list with a simple line of code, but in regarding tuples, it is immutable. Try to change coordinates and Python throws. If you try to change any index or coordinate, the Python throws is in type error. Tuples are used when you want to protect data from being accidentally changed, like GPS coordinate, RGB colors or database records. And then comes the dictionaries. Dictionaries are incredibly powerful. Each item will be written in a dictionary like a key value pair separated by a colon like this. You access values by the key, not by position. Adding a new key is as simple as in this, if you want to add a new key, you can put it like a info of square bracket topic that will and you want a variable in it, you can simply add like this. So this code I already run by mistake. Okay, so this is the key and values. If you want to put another one, variables, you can simply give like this. In this info info variable, we can give this topic, key is this topic and variable as value of topic is variable. Like this we can assign. That is as simple as that. And then sets automatically. Sets means it automatically removes duplicates. Look at the example. We put 1, 2, 3, 2, 2, 3, 3. So in a set, and Python gives back only 1, 2, 3. You can run it by your own. It will not give the repeated values or duplicates. So the quick summary is: list is for ordered changeable data, tuple is for ordered fixed data, and dictionary is for named data, and set for unique data. And then comes the type of. This type of tells you exactly what type a variable is. Look at this code here. Type of X. Type of X means it will give you the class integer. Type of name is class string, and type of pi means it belongs to float. And we can also do the type conversion like this, integer to float. If you want to convert this integer 10 to float, you can simply give float of 10. That will give the same value with a decimal point. So you can do any conversion like this float to integer if you want, int of 3.99, it will give the only the integer value by removing the decimal part. And then comes the naming convention in Python. Here's something that separates a beginner Python from a professional Python. Naming convention means Python has an official style guide called PEP8. The Python enhancement proposal number PEP8 means Python enhancement proposal number 8. That has two types of means naming convention. That is snake case for variables and functions. That is all lowercase. In this type of naming convention, all lowercase words separated by underscore. So user underscore name like this, small letter only we can use. Get score like this. Calculate average. This is a standard for everyday. This is actually a standard naming convention for everyday Python code. And another naming convention is Pascal case for class names. Each word starts with a capital letter, no underscore. So it will be written like this: student profile. Each word starts with a uppercase letter, and you can practice this from beginning onwards. Like I'm not going into the details. I have written a code with all the details about the naming convention. You can go through it and you can practice it by your own while naming. If you practice it from name on means day 1 onwards, it will be useful for you. And then here is a live code challenge. Actually, this is the moment I have been building towards throughout this video. Let us write a real Python program using everything we have learned today. We are going to build a student profile program. Just open your Jupyter notebook and follow along with me. I have already written the code like this. First we set up our variables. Name is a string, episode is an integer, and rating is a float. Is enrolled is a Boolean. Subject is a list. Notice it holds strings inside, and info is a dictionary with the episode number and rating. Info here is a dictionary with a key value pair with the episode number and rating. So now we display everything using f string as discussed before. So notice how we embed each variable directly inside the curly braces inside the f string. Just carefully go through it. We also call type of rating inside the f string to show the type, and it works perfectly. You just run it. So you can see the output. In just 12 lines of code, you have used 6 different data types, f strings, the type of function, and the proper PEP8 naming. That is a complete real Python program which cover all the topics we have covered today. Now the challenge is you can just modify this program, add your own name, add more subjects, and add a new key to the dictionary. Run it and see what happens. Drop your output in the comments. I read every single line of your comments. So everything covered in this tutorial is written as a full blog article on intuitive-tutorial.com with code snippets, explanations, and downloadable examples. The link is available in the video description and pinned in the first comment below. So go there to read at your own pace, copy the code, and bookmark it for your reference. Learning works best when you combine watching with reading, and that is exactly why the blog exists. So before you go, if you find this video helpful, I would like to request you to consider subscribe and like, and also share the feedback to make me informed on your thoughts, which will help me to improve every day. See you in episode 3. And until then, keep coding, remain curious, and remember, you have the same tools as every AI engineer at Google. Use them confidently.